Hello, Cardinals. We're going to talk about reflection for lesson 7 today. We're on page 65 in our notebook, and our focus question is what happens to energy when two objects collide? Our word of the day is rationale. Rationale is a set of reasons for a course of action. So in your work today, you should try to include the word rationale a few times. Looking back at yesterday's data, you should have noticed that the collision was different than in 7.1. And that for the most part, car A, after it collided with car B, went backwards. And then car B did not go as far as it did when it did not have weights in it. So the thing to learn here is that the heavier a car is, the more energy it takes to move. And then that energy doesn't all go into car B. Some of it goes back into car A and makes it go backwards. When you get a little time, you're going to want to go through your objectives and look at number 2. And you're going to want to discuss how collisions are different if two items have different masses, and then use some examples from your lab, some diagrams or some drawings to finish that. And then we're going to look at our vocabulary. We had 6 vocabulary for lesson 7. We want to make sure everyone has that down. Shifting responsibilities from you. You should have this in your notebook already, but in case you don't, I'm going to flip through the vocabulary pages for you. The first one is conservation of energy. Energy cannot be created or destroyed. It can only be transferred from one object to another or transformed to another type. So the energy flows through objects, and or it can be turned into heat or sound. Lots of different options for what it can turn into, but energy cannot be created or destroyed. It can only be transferred or transformed. Sometimes it might appear that energy has been gained or lost, but it's because it came from or traveled from somewhere outside of the system. So, sometimes it might appear that an object had gained energy or lost energy, but that's not the case. It's just that energy came from somewhere outside of the system. Energy transfer is energy moving between two objects or systems. We have a little picture here of a kid pulling a wagon, and then as the kid pulls the wagon, it's gaining potential energy, and it's coming from pulling that wagon up a hill. So that object, the transfer from that energy is coming from gravity going into the system of the girl pulling the wagon. And then energy transformation is energy changing form within one systems or another. So the idea is that if she let go of the wagon, how would it, it would roll to the bottom of the hill, and how would that be transforming energy? Well, the energy would be transforming from potential to kinetic energy. Here are 3 different examples. You have solar panels, tennis racket hitting a tennis ball, and plants, getting energy. You should be able to decide which ones are transferred and which ones are transformed. Another vocabulary word we went through is momentum. Momentum is anytime an object with mass is moving with a velocity, it has momentum. So if an object has mass and it's moving, it has momentum. Momentum's formula is mass in grams times velocity in meters per second. So as you look at the football players here, if they're both moving at the same velocity, the smaller player would have less momentum. And then if they had the same mass, so this is the same runner, the person running would have more momentum because their velocity is more. So just a little mathematical equation, mass times velocity is momentum. Conservation of momentum states that momentum doesn't disappear during a collision. It's transferred from one object to another. So the momentum of the marble on the left would transfer through all the other marbles and then exit through the marble on the right and go back and forth. And then today for your reflection, you're going to be creating a model that describes the total energy of car A and B in your investigation. You're going to be including a diagram, a graph, and a written explanation for this. You're going to want to read the physics of a car crash and answer the discussion questions. We're going to be discussing how collisions demonstrate Newton's 3 laws of motion. And if you think back to your readings and investigations, you're going to find evidence for those. And then number 4 is going to be asking you to evaluate a new law that's proposed from a local government. This is a fictional law, but one that we could discuss. And the law would state that for all SUVs and trucks, they would have to travel on the highway 15 miles an hour slower than cars and motorcycles. It would apply to speeds 40 miles per hour and over, and they'd be asked to stay on the right-hand lanes and travel slower. So you have to work through how that law would work. You need to write an explanation of why the law would be proposed. You need to include data that would support or that you need to write some. You need to include some data that would support this law based on your investigations. You also need to realize that your investigation may not have been perfect and may not be adequate to educate citizens. So you need to decide what other things you'd have to add to your investigation to make the citizens more educated with the law. And then we're going to be discussing the evidence that you gathered in your investigations, and you need to be able to share your thoughts on this law. So your to-do list, you have 7 items to do for your reflection. And then prepping for tomorrow, you have a lesson 6 and 7 quiz Monday, and we're going to be starting our notebooks, or we're going to be checking our notebooks Monday also. Have a great day, Cardinals.